All right, hello everybody. This is Gigi from Kauai Community College. In this video, we'll go over the divergence test, just brief, short video. Okay, so let's get started. Now, from previous experience, you probably have seen what we called truth table and logic statements, right? So if we just take a look at this right here, I'm going to call your attention to the conditional statement, if P, then Q. Okay, now which one of these blue columns here has the same truth value as if P, then Q? Okay, now if you think about it, and you will see that the contrapositive have the same truth value, right? So in logic classes, we would say that the conditional statement is equivalent to the contrapositive, or the contrapositive is equivalent to the conditional statement. So you can use one or the other to rephrase your statement, right? Now, what does this all mean? I'm going to give you an example here. Suppose that your conditional statement, if P then Q, reads, if it rains, then the ground is wet. Okay, if it rains, then the ground is wet. So this right here is your P, and this right here is your Q. Yeah. Now the contrapositive, not Q, that squiggly sign means not Q. If not Q, then not P. Well, how do you state in words the contrapositive of this statement? Well, if Q is the ground is wet, not Q would be the ground is not wet, right? So the contrapositive here will be written as, if the ground is not wet, then it did not rain. So these two statements are equivalent. They're the same, logically the same. Okay, now why is this useful? Because we use the contrapositive to rephrase a conditional statement, and most of the theorems in math are being stated using a conditional statement. If this, then that, right? So here is what I mean by this contrapositive being used to rephrase a statement. Well, suppose that the theorem in math said, if the series converges, then the limit as k goes to infinity of a sub k is going to equal to 0. Okay, now why is this called a divergent test? When the statement is saying if it converges, then the limit is 0. Well, that's not saying what it means to be divergent, right? So we use the contrapositive to rephrase this, okay? And it's more useful than the original statement. So P means, P in this case is the series converges. Q is the limit is 0, right? So the contrapositive is not Q, then not P. Well, in terms of mathematics here, rephrasing this theorem, we would say that if the limit is not 0, then the series diverges. Okay, so this is more useful. Why? Because we can take the limit. Okay, most of the time we can take the limit, and we know how. All right, so here let's see an example. So there's the series there. Okay, now we take the limit as k goes to infinity of k over k plus 1. And that has the form infinity over infinity. So L'Hopital rule will apply here. And we take the derivative of k, which is 1, derivative of k plus 1, which is 1. So the limit is 1, and 1 is not 0. So we would say the series diverges using the divergence test. Okay. Next, if you have this series here, okay, take the limit as k goes to infinity. Well, we know that that limit is 0. Well, what does the divergence test say when the limit is 0? Nothing, right? It said that if the limit is not 0, then the series diverges. Okay, so again, this cannot be used. Divergence test is inconclusive. So what do? Try something else. Okay, that is it for this video. Up next, we'll talk about the integral test.